but you're told that you have a regular polygon with a side length of 12, so you know your S value is 12. And you want to find what the area is for a regular octagon. So if we're dealing with an octagon, what's the number of sides going to be? 8. So the only thing that we need to complete our area formula, 1/2 SAN, we have the S value, we have the N value. All we need is the A value. Okay, so in order to find the A value, we're going to use a reference triangle. You don't need to sketch the whole thing. If you just sketch an isosceles triangle as your reference, you know there's going to be 8 of these rotated about, so the angle for each of these vertex angles will be 360 divided by 8. When you divide 360 by 8, you wind up with 45. So that vertex angle is 45, which means when you draw in your apothem, the one measure that you need to solve for, it's going to cut that angle in half, so each of these angles will be 22.5. It's also going to cut this opposite side in half. So if the whole side was given as 12, when we draw the altitude, it cuts it into half. We get a 6. Okay, and so now we can set up and solve for our apothem measure. We have an angle, we have an opposite side, and we have an adjacent side. So opposite and adjacent are related by which trig ratio? SOHCAHTOA, so tangent. So we know that the tangent of 22.5 has to equal the ratio 6 over A, which we can then solve. Multiply both sides by A to get the variable out of the denominator. Divide by tan of 22.5 to isolate our A. And so here is our apothem measure. 6 over the tan of 22.5. And so we simply put that into our calculation. Okay. And then this would give us the area that we're looking for. Okay. It's very consistent, okay, this process. Okay. Now the questions come up, because I know a lot of you like to use law of sines instead of trig ratios. Is that correct? You understand that you're adding extra steps on it, right? Okay. But since a lot of people like to use that, the other option for this, you can do this using law of sines instead of tangents. Again, anytime I've shown this, I've done it with a tangent. But if you're going to use law of sines, what you would need to do is you'd need to find this angle right here, this other acute angle of the right triangle. And so if you were to take, you know that the acute angles of any right triangle add up to 90 degrees. They're complementary. So if you were to take the complement of 22.5, you could find that this angle is 67.5, and now you can set up your law of sines. You could say that A over the sine of 67.5 is equal to 6 over the sine of 22.5. So you can still solve it this way. It winds up giving you the same values.